SIP and fax over IP. In this module we're going to take a close look at faxing, which of course works great over the PSTN, and see how it works or doesn't over IP. The elements we'll cover are the faxing basics, fax over IP, the various fax protocols you will encounter, fax over IP in action, bandwidth requirements, troubleshooting tips, the ongoing efforts by some major forums, a summary, followed by a quiz. Before we dive into fax over IP, let's have a quick refresher of the basics. Facsimile is Latin for made alike, though the popular term is faxing. The basic principle of faxing is that you have a document that you need to get to some distant place right now. It may be that the person you want to send the document to will not accept a copy of your signature in a PDF format, so scanning an email is out of the question. Either way, this is your need. The fax machine was patented in 1843, though fax machines were not widely used until the 1970s. Fax machines have always used the good old PSTN. There are hundreds of millions of fax machines out there, and they all speak the same language. That's a protocol called T30, and because of this legacy, fax over IP as a technology will need to be able to connect somehow with all of these existing machines, or it will never be accepted. We'll see that having to talk to all of these machines across multiple network connections brings a big set of issues. Although this module is about fax over IP, we need to make some note of how T30 fax signaling works, as these signals are important to fax setup and will be encapsulated in IP packets and sent across an IP network. So let's look at the signals they send to each other to establish a connection. First up, the sending fax emits a calling tone, or CNG, that is meant to alert the recipient that a fax machine is trying to connect. CED is the answering tone to alert the sender that it has connected to a fax machine. So far so good. Next, the receiving fax sends a digital identification signal, DIS, which specifies the unit's capabilities such as data rate, etc. This is almost like an options menu that the sending fax can choose which capabilities are a best match, and then by returning a digital command signal, DCS, the transmission parameters chosen are then used in the session. The receiver then detects the DCS and the transmission can advance to the next phase. After a training check message, TCF, the receiving fax will send a confirmation, CFR, that it is now ready to move on to the next level and receive the fax document. After the fax has been sent, the sender sends a return to control RTC code, then an end of procedure EOP signal, indicating that there are no more pages to be sent. The receiver acknowledges this with a message confirmation MCF, which indicates that the fax was received. To finish the call, the sender sends the disconnection DCN message. There are of course other fax messages, but we've focused on the basics here. The tones shown here are all defined as various standards, and V21 defines the initial tones. V21 is the handshake signaling and used mainly before and after each page. V27TER, V29, V17 and V34 are the protocols used for actual fax data transmission, and you can see the speeds of these in the table, with more detail available on the wiki link. When it comes to standards, you will find that in the world of faxing, the Group 3 specification is pretty much the de facto standard, as it superseded G1 and G2 a long time ago, and G4 hasn't taken off at all. Group 3 spec was formed by the International Telegraph and Telephone Consultative Committee, CCITT, which is part of the International Telecommunication Union, ITU. The ITU link here points to the T38 standard documents, and as an added reference, If you click on Attachments near the top right of this screen, you will see a link to the ITU site that lists all of the V standards. Of course, this section is all about sending faxes over IP networks, and we'll talk the detail in a moment. First, there are many reasons for moving to fax over IP, and here they are. Lower costs than sending across a PSTN network, as you can use your internal VoIP infrastructure for internal faxing and your ITSP for external faxing. This means you can even remove those old lines your fax machines needed. Fax servers need fax boards, and these can be expensive. If you can send over IP and not the PSTN, you can eliminate these hardware costs. Fax servers are easier to scale when using IP, and users across WAN links can now send and receive faxes without needing a local fax machine or line. Consolidating data and voice onto one cabling infrastructure is also a big benefit, and in the case of fax, it is now treated as simply more data on the network. If you are consolidating equipment and implementing fax servers, then you'll save money on power and paper. Fax is a key component of unified communications, as people can use the fax service from UC client software, and the UC infrastructure can apply business rules and logic to control the sending of the faxes. Okay, enough of the background. Let's take a look at fax over IP networks. Let's look at how things are moving to fax over IP on a network with an example. Here you can see a bunch of fax machines connected to the PSTN, and the voice PBX is also connected to the PSTN using TDM. Now let's remove these separate faxes and replace them with a fax server. The fax server still needs to connect to the PSTN, and this is where fax boards come in. People can now fax from their old PC to the fax server and out. Some departments may not be happy with this and still want their old fax. Let's bring one back, and it's line. Now, one way to take advantage of a VoIP infrastructure is to use a fax server that implements fax over IP and sends all the faxes to the IP PBX for transmission over the TDM link. Great, now you've removed the need for expensive fax boards and their lines, though you will need to ensure your existing lines and PBX can cope with this added demand. Let's move on. A lot of voice services can now be provisioned by using voice over IP across SIP trunks to an ITSP. We know all about the benefits of this, so I won't go on about them here. But now you can see that the TDM link has gone and been replaced by SIP trunks. So how does this affect our fax situation? Well, now if the fax server is using fax over IP, its faxes are turned into IP packets and should traverse the SIP trunk fine using a protocol called T38. More on this in a moment. But we've still got an existing fax with its old TDM line. What you can do here is buy a gateway that will take the connection from the fax and then convert the fax for sending over IP using T38. One thing that this screen is designed to show you is that conversions can be the cause of problems, especially if there are a lot of them. Here you can see the T30 fax is converted to T38 to traverse the SIP trunk. A gateway at the ITSP will probably need to convert back to T30 for transmission to a PSTN connected fax. If the destination fax has to traverse the PSTN to another ITSP that provides T38 to its own client, then the fax has to be converted back again. Surely this will add delay to the transmission of T30 signaling and fax data. And doesn't delay cause issues? Well, we'll see. So far we've mentioned very briefly that Fax over IP can implement the protocol T38. Well, let's look at some options here. There are basically three types of Fax over IP: pass-through, T37, and of course the aforementioned T38. Let's look at them in detail. G711 pass-through is basically the same as a VoIP call, and here you can see that from one office location to another the fax is transmitted using G711, which utilizes the RTP protocol to transport the fax. In the case of the fax needing to go to someone across the PSTN, the G711 transmission would need to go via an ITSP, who would then need to convert it back to T30. Let's take a look at some positives and negatives of G711 pass-through. G711 is a simple protocol to understand, as it's been supported on networks and manufacturer equipment for years. It works in real time, something that users of faxes are pretty insistent on. G711 operates as a VoIP call and uses not only RTP to encapsulate the fax data, but also RTCP, which is great for reporting and notification functionality. It can be faster than T38 when V34 is utilized, though both fax machines need to support this. Super G3 is the spec that defines V34 in fax usage. As the fax is transmitted over IP, it can be affected by the things that affect VoIP calls, such as delay, jitter, and packet loss, all of which can kill a fax transmission. G711 is more bandwidth hungry than T38, and we'll see a slide on this later. With this in mind, you can't use a compression codec, as these will destroy the fax signals. And some companies are keen to use G711, as then they can send faxes securely using SRTP. T37 is a standard that specifies how fax documents can be encapsulated and then sent as an email. Here a document is scanned in by the fax machine and T30 is used to transmit the document to the gateway. The gateway then processes the fax and attaches it as a TIFF formatted document and sends it in an email to the remote gateway. The remote gateway then processes the email, negotiates with the local fax, and passes the information across to it for printing. To add to this, incoming faxes from the PSTN can be converted by the now on-ramp gateway, on-ramp because it's receiving the fax, and passed on to a user's mailbox or a general mailbox folder for all to see. Incoming faxes could be received via T38 fax trunks or the PSTN using T30. Either way, the gateway will convert the fax and pass on to the email server for delivery. T37, also known as Store and Forward, is a simple standard that utilizes the very well-known email protocol SMTP. It's also very reliable, though not widely used, so we'll keep things short here. In essence, with T37 you can send a fax from your PC or other multifunction device, which then via the fax server delivers the fax to other fax machines across the net. Faxes arriving at your building will be converted and delivered. Unfortunately, faxes cannot negotiate and tell each other of capabilities, i.e. colour, and don't expect a delivery receipt. Finally, one of the biggest issues people have with T37 is the fact that it does not operate in real time. Faxes may be delayed in the fax server or email server and waiting for processing, when the sending person has the impression that it has been delivered. In T38 fax relay mode, gateways break down the T30 tones into frames and send them across an IP network using the T38 protocol. T38 data is converted back to T30 tones at the receiving gateway. In effect, the fax machines are unaware that their signals have been converted a few times along the way. T38 is becoming the de facto standard for real-time fax. It does have methods for replacing lost packets that seem to work quite well, so on this count it beats G711 pass-through. There is the facility for receipt confirmation, and it also includes the ability to fail over to another connection if the primary connection is not available. T38 is also less bandwidth hungry than G711, and the protocol itself is defined by the ITU, though the IETF has related documents such as 3362 that describes T38 over UDP-TL, and the newer 4612 that describes T38 over RTP. Let's take a quick look at the TCP/IP layers to see where all of this fits in. We're concentrating on SIP along with SDP being the signaling to control the fax session, and you can see it here running over UDP usually, and then IP. G711 pass-through, just like a VoIP call, delivers the payload in RTP over UDP and IP, whilst T38 is currently using another protocol called UDP-TL. UDP-TL will be explained in a moment, but you can see that T38 could at some point utilize RTP instead. UDP-TL or UDP transport layer is at this point in time pretty much the de facto for T38 transmission, and it works. You can see the UDP-TL element here with a sequence number, and it is carrying T30 fax information. You can see that V29 is the emulated protocol running at 9600 bits per second, and here is the digital version of the fax signal. Also, you can see the secondary packet that's used for error correction, so if the previous packet was lost, its data is provided here for recovery. Let's take a UDP-TL or UDP was lost, its data is provided here for recovery. Now let's see if there is some other way to make this better. These are ideas and not something you may see right yet, but we say, why not? So let's take our two pieces of fax in the T38 element, by the way, IFP means Internet Fax Protocol, and pass it over RTP, not UDP-TL, and see what we gain. Well, RTP is a very well known and supported protocol on all manufacturers' equipment, so less likely to have interop issues than UDP-TL. RTCP, the sister protocol to RTP, brings reporting features that can gather statistics on the RTP stream to be used in possible fax receipting or notification delivery messages. You can even secure the RTP stream using SRTP, and the RTP header can even be compressed using CRTP. While we're at it, we could push the RTP stream over TCP to give us a connection-oriented setup that will ensure lost packets are redelivered. This means that we don't have to rely on the sending of previous packets in each T38 element. Now let's see if there is some other way to make this better. These are ideas and not something you may see right yet, but we say, why not? So let's take our two pieces of fax in the T38 element, by the way, IFP means Internet Fax Protocol, and pass it over RTP, not UDP-TL, and see what we gain. Well, RTP is a very well known and supported protocol on all manufacturers' equipment, so less likely to have interop issues than UDP-TL. RTCP, the sister protocol to RTP, brings reporting features that can gather statistics on the RTP stream to be used in possible fax receipting or notification delivery messages. You can even secure the RTP stream using SRTP, and the RTP header can even be compressed using CRTP. While we're at it, we could push the RTP stream over TCP to give us a connection-oriented setup that will ensure lost packets are redelivered. This means that we don't have to rely on the sending of previous packets in each T38 element. We've covered a fair amount of faxing theory so far. Now let's see this in action. Looking at this setup, we have a sending fax machine connected to a gateway that will use SIP to set up the session, and T38 to transfer the fax. Of course, at the ITSP, we have a SIP server and a fax gateway. After the fax communicates with the gateway sends out the SIP invite to start the session. The server passes this onto the fax gateway that responds with trying, then 183 progress, and after a while the VoIP channel is set up. Once the fax tone is detected, the gateway will send a re-invite. It could send an update instead, and this asks to switch from a VoIP call to a T38 session. This is passed to the sending gateway. This gateway acknowledges, and after a while the fax is transmitted using T38. Once the last page has been transmitted, the session is taken down. All of the time this is going on, the two fax machines just think that they are talking T30. Looking at this setup, we have a sending fax machine connected to a gateway that will use SIP to set up the session, and T38 to transfer the fax. Of course, at the ITSP, we have a SIP server and a fax gateway. After the fax communicates with the gateway sends out the SIP invite to start the session. The server passes this onto the fax gateway that responds with trying, then 183 progress, and after a while the VoIP channel is set up. Once the fax tone is detected, the gateway will send a re-invite. It could send an update instead, and this asks to switch from a VoIP call to a T38 session. This is passed to the sending gateway. This gateway acknowledges, and after a while the fax is transmitted using T38. Once the last page has been transmitted, the session is taken down. All of the time this is going on, the two fax machines just think that they are talking T30. So now let's replay the signaling and point it out on the Wireshark trace. Here you can see the initial invite to the SIP provider, which responds with 100 trying, 183 session progress, and then a 200 OK. This sets up the VoIP channel. On detection of a fax signal, the ITSP fax gateway sends a new invite to the sending fax requesting a T38 session. So this is the first invite message sent from the sending fax's gateway to the SIP server at the ITSP. You can see the request line has the destination fax number appended with the ITSP's SIP server fully qualified domain name. Here is the sending fax server's number. In the SDP body, you can see that the invite is requesting an audio session first of all. So this invite is from the SIP server after it received one from the ITSP fax gateway. This invite is being sent to the sending gateway address. You can now see that the media description highlights the desire to send an image to port 36116 using UDP-TL for a T38 session. Other fax attributes are shown here, but believe me, these are not the only ones you will see. Let's zoom in a little on the next page. So here we can see that the SDP body contains what's called capabilities of the fax gateway at the ITSP. Capabilities are described in RFC 3407. For a session, there is a sequence number always starting with 0. This number will increment if the capabilities of the fax change during the session, i.e. it wants to not support voice during the session. Maybe the DSP can't cope. CDSC, or Capability Description 1, means that the fax gateway supports audio using the G711 codec, i.e. audio RTP AVP 0. CDSC 3 shows that the fax supports image transfer using T38 at the same time as it can support an audio stream. CPAR attributes are capability parameters, and here are the ones for our sessions shown. T38 fax version 0 is the version number of the ITU T38 recommendation. If there is no parameter, then it's assumed to be version 0. T38 fax rate management, transferred TCF. This indicates the fax rate management model as local TCF or transferred TCF. Local indicates that the bit error rate is identified on the receiving device, whereas transferred refers to the bit error rate on the sending device. You'll see transferred TCF when utilizing UDP-TL. T38 fax max datagram 160 shows the maximum size of the payload within an RTP packet that can be accepted by the remote device. T38 fax UDP EC, T38 UDP redundancy relates to error correction, and T38 UDP redundancy is quicker though less sophisticated than the other option, T38 UDP FEC. Of course, there are more, and here's a table taken from the i3 forum document you can find in the attachment section that shows both mandatory and optional parameters. Here's a Wireshark trace of a fax call using T38. Frame 32 shows the initial invite, and the invite goes out to the external fax number. The audio channel is set up, and this lasts a while. G711 still in place, and then an invite from the receiving fax to the sending fax requesting a switch to T38. Here's the acknowledgement, and now we're using T38. T30 signaling, and if we move down to frame 481, we can see the DIS signal, the menu of options available from the receiving fax. Frame 549, the called number, Frame 560, the digital command signal. Some training signals. And on 688, the confirmation to receive signal. (734) sees the start of the fax data. If we look inside the packet, there is some of the fax data. This continues for a while. On frame 2574, the end of retransmission signal. (2646) message confirmation. And 2756, bye. For more information on some of the elements you may find in an SDP body, plus more core flow examples, it's worth taking a look at this draft document from the IETF. All of the described protocols use up bandwidth on your network. Let's see how much. Just glancing over the table shows that T38 is a slower protocol than G711 for each V protocol, and demonstrates that people may choose G711 pass-through when big documents need to be transmitted quickly and often. As bandwidth becomes more available to companies, it becomes less of an issue using a protocol that generates more traffic. We previously mentioned that fax elements are resent in subsequent packets to give some kind of redundancy if there is packet loss on a network. Data redundancy is an interesting thing, and the level of redundancy can be changed. Depending on the R value, one or more copies of previous packets will be transmitted. So a value of R3 means a packet includes a copy of the 3 previous payloads. One thing is for sure at the moment is that one of the most popular configurations around the world is V29 at 9600 bps, with V17, 1400 and 400 bps also being used a lot. T38 is proving to be the dominant force in fax over IP today. Now let's have a look at how to start troubleshooting issues with fax over IP. Let's start with the basics. First of all, draw a topology of your network and be amazed if there is a gap. Next, if a fax to one location doesn't work, try sending to another. This will at least prove your fax machine is working okay. If faxing across a WAN link doesn't work, then does a VoIP call? If not, then you have to sort the VoIP element first, otherwise fax over IP will never work. You could quickly plug your fax into an old analog line, if you still have one, to again check the fax works. Check the bandwidth available and monitor this when sending a G711 fax over IP transmission. G711 fax uses a lot of bandwidth and it may struggle over a slow connection. It's always good to check the fax manufacturer's website for any known issues, and if there are still problems, well, it's out with the network tracing tools such as Wireshark. And whilst we're talking networks, why not check that all the cabling is connected correctly? Even try another switch port. So, as it's really hard to find any formal troubleshooting methods for fax over IP, this selection of items is here to serve as ideas you can try in order to fix issues you may have, and also be thought-provoking in a way that will help not only in current fax deployments, but future ones. Slow SIP response results in T38 reinvite failure. So this is where, for example, a 200 OK that the terminal had answered as VoIP is followed by a late reinvite to switch to T38. To fix this kind of issue, you have to look at your network and attempt standard VoIP delay troubleshooting techniques. In fact, it's the switchover from voice to T38 fax that causes most issues, so make sure your network is trouble-free. On this note, it's always wise to monitor, test, and adapt your network as much as you can to reduce delay, jitter, and packet loss, and ensure QoS mechanisms are enforced across your own network, and if using one, the carrier MPLS network. T38 version 3 may help, eventually. The next deployment of T38 version 3 will mandate that the gateway at the ITSP, for example, mutes the audio path in both directions as soon as it determines it needs to switch to T38. This is done so that the T30 session stops from progressing too far past the point of no return. The big issue here is that all providers will need to upgrade their gateways to this new version, and we know that this is going to take some time, so no quick fix here then. V34 fallback to V17. Not all faxes support V34, so if a V34 fax is trying to communicate with one that is not V34, the V34 fax should fall back to V17, which is far more common. So if a fax tries to use G711 pass-through and a gateway that it reaches doesn't support this, will the gateway and the fax renegotiate to fall back to T38 relay? If not, why not? Is this the problem with the fax machine or the gateway that's being used? For an expanded view on V34 to V17 fallback, check out the link here. Go slow and turn stuff off. It's not ideal for speed of document transmission, but sometimes changing speed settings to 14400 or even 9600 on both fax machines can help, along with disabling error correction mode. ECM is required for V34 color faxing and MMP compression, so this may not be an option for you. Yet, if your carrier's gateway does not support ECM, then you've got some great fax features that you cannot use. It's now up to you if you still need to send that fax, but in black and white. Codec issues. G711 is the only voice codec that really works in pass-through mode, as it doesn't compress and potentially garble fax tones. V21 fax messages only run at 300 bits per second, so in theory, a low bitrate codec such as G729 should carry them. But when the switch to V29, for example, happens, will an 8K codec be able to carry the 9.6K or above fax signals properly? I don't think so. If you have G729 SIP trunks running in your organization, you're going to have to add some G711 trunks and use G711 pass-through. Effects of echo. Echo cancelling suppressing functionality may actually cause problems with fax setup tones and even cause the switchover from audio to fax transmission to fail. As a default troubleshooting action, disable echo cancellers suppressors then check out the detail in the i3 forum document for more information. T38 relay over multiple hops. One of the biggest issues facing T38 fax is the sheer number of interconnects that a fax may face on its journey. Lots of carriers and lots of gateways all must ensure that the T38 session works effortlessly and without delay and loss that haunts fax over IP, especially the switchover stage from the voice call to the T38 session. It's hard for an enterprise to actually test what's happening without access to the provider's network and testing equipment. So for the purposes of troubleshooting, it may always be wise to have a SIP account with another provider that offers T38 to see if they get the same issues as your current provider. It's all about gathering clues to help solve the fax puzzle. Gateway capabilities. In order to cope with fax over IP, gateways need to be looked at closely so that you can be confident that they can provide the amount of fax sessions you need at any point in time, as well as being able to cope with the processing demand of the required sessions. Does your gateway have a powerful enough processor and enough RAM? Are questions you should ask of your gateway provider, as you may need an upgrade to get things working smoothly. Although T38 is not a new protocol, it's only recently, when trying to run it across SIP trunks, have issues arisen that highlight provider interop issues, along with equipment manufacturers' needs to work hard on testing their implementation of T38 in accordance to standards. There are no real testing procedures in place, and it's the goal of the SIP Forum FOIP task group, along with the i3 forum, to provide these, though until published, you're on your own. The links on this page will get you to the following: the SIP Forum website and details on the partnership, the problem statement from the SIP Forum, the i3 Forum homepage, and the technical spec for FOIP published by the i3 Forum. It's clear that getting millions of fax machines connecting to each other using their built-in protocol over an IP network that can traverse multiple carrier interconnects is a troublesome endeavour. But as the world is moving to a completely IP-based network for telecoms, it's a one-way street to fax over IP, so everyone needs to pull together to ensure that fax over IP starts to work as good as it does over the existing PSTN. Here is a reminder of the organisations heavily involved in the evolvement of fax over IP. The SIP Forum has been working hard with its fax over IP task group, and along with the i3 Forum, been responsible for RFC 6913. Let's see how this helps. Here, Graham sends a fax to Lynn's SIP address. Lynn actually has two devices registered with that address, a fax device that has a phone, and also her mobile device. In this instance, both will ring, and it's going to be messy if the fax is attempted to be sent to the mobile. RFC 6913 defines a new tag, sip.fax, that devices include in their registration message to their servers. This means that a calling device can actually request that only devices that are fax capable and have registered with this tag will be used. One thing to remember is that not all devices will have implemented this new tag. So a calling device, if it finds there are no devices that have registered the new tag, will fall back to the older method of trying them all. Here you can see Lynn's registration message from the fax machine to the SIP server, and within it there is the new tag. Here is Graham's invite from the fax machine that requests connection to a device that has registered with the new SIP.fax tag. Note that the tag here defines the fax over IP method T38. Pass-through can also be requested by using this example tag. T37 is not supported. In our trace examples earlier, you saw that the V21 T30 tones were all carried as audio, and there was the need for fax detection to make the switch over to a T38 fax session. Well, it is recommended by the i3 and SIP forums that these tones are carried as DTMF telephone events in an RTP packet, instead of being carried in a G711 RTP packet. Doing this would mean no need for the initial audio channel, therefore no switchover required, and as switchover failure is one of the main issues affecting fax over IP, full adoption of this method based on the RFCs shown here, with 4734 being the latest, is to be strived for by all. The easiest way to summarize this module is to say that fax over IP mostly works quite well, but mostly is not good enough for a technology that people are used to working always. T38 is emerging as the preferred protocol to work with in the industry, but there is a big need for all manufacturers to deploy equipment that has the latest version of the protocol implemented. Only then can we enjoy error-free faxing across multiple gateways, deployed on multiple sites, linked by multiple carriers. By clicking on the attachments link at the top of this page, you'll see some sites and documents that we like and think complement this module. Forums such as the SIP forum and i3 forum are to be commended on their efforts to define best practices for deploying FOIP and for also looking to set out standard troubleshooting practices. It would be wise to keep an eye on how things develop with these two, but in the meantime, it seems that to get FOIP deployed and working, you need to think carefully about the equipment you have, where it is located, what its capabilities are, and what you can expect to get when deploying alongside gateways. Finally, be realistic in your expectations when working with fax over IP today. Expect to have to work hard to make it work, and take the tips from this module on board. Welcome to the questions section of fax over IP. This section is designed to test your new knowledge and will present a number of questions and different question types. If you fail the section, please take time to review the material and try the questions again. Please note, this quiz does not constitute part of the SSCA certification test. SIP and fax over IP. Welcome to the question. Now you've got to the end of this module, please return to the route map, and if you are happy that you have both completed and understood the content, you can change the module status on the route map to completed. And remember, even if set to completed, you can still revisit the material.